No one will ever know.
No, no one will ever know that I cuss like a sailor. And I'm the one who cusses the least in my family. Okay. What else can I help you all with? If you got nothing, I'm going to pack it in. I swear. I swear. Don't make me call on you one at a time and see if you have any questions. I will do it.
I'm trying to give other people opportunities to ask questions.
Well, they're not jumping out there. So if you have more questions, Izzy, go for it until someone says, wait a minute, it's my turn.
Stephanie has a question.
Okay, I'll go after Stephanie.
Go for it, Stephanie.
Regarding the lab, so where we have to like do the formula for sodium acetate, so is it C2H3NaO2?
Sodium acetate. There are many different ways of writing this.
Okay, because I wasn't sure. And then when I saw silver acetate, they just put like, because I looked it up because I wanted to double check AG in the front and then acetate. But is there like a specific way that we have to?
So the acetate ion looks like this. That's how all the atoms are connected together. So you can see there's 2 carbons, 3 hydrogens, and 2 oxygens. So this is one way to write the acetate ion. Another way is you write this part first like this, CH3. And then you write this part as CO2. And with a negative sign. And a third way to write it is this way, CHCOO. These are all the acetate ion. So if you want to write the formula for sodium acetate, it can be any of these and I will take it. And this is the problem with going to the internet is some people, you will see them write the sodium acetate this way. Some you'll see it this way. Some you'll see it this way. And I've even seen it this way, where that's supposed to be acetate. Don't do that, because there's an element that has AC in it. Okay, so does this kind of capture what you were asking, Stephanie? Which one is correct? They're all correct?
Yes.
Okay, so I'm going to put little check marks here because they're all correct. I like this one the best. And the reason for that is you see these 3 hydrogens? You can't tell one from another, so CH3 is perfect. But you see these 2 oxygens, one has a double bond, one has a single bond, which means they're different. So I put COO because you may think that those oxygens are somewhat different. Otherwise, I'd say O2. All right. So what else can I help you all with?
So I just wanted some clarity with, I'm kind of unsure what I'm talking about even because there's just a bunch of things scrambled up in my brain right now. But when you do like, I'm pretty sure maybe it's mass percent when you do like a certain amount of moles, the ratio to the moles of the whole compound instead of with percents.
Well, there's a problem in our in your assignment for hydrates. Okay, let's take a look at that. Okay, and it deals with mass percent. So I'm going to get rid of that chrome. I really don't like chrome, but I have to use it to use Proctorio. So let's see. I want to go to module 2. And the formula of a hydrate for mass data. Whoops. Gosh darn it. Here we go. Formula of a hydrate from mass data or data. If you look at this last problem here, Oh, my bad. It's not here. It's in it's a homework problem. Okay, let me find out. Well, actually, I don't know what homework problem it is. I do remember what it asks for though. So this here is a hydrate, and you can't see that because I'm sharing the wrong thing with you. This is a hydrate. You should know how to name this. So try to name this. I'm going to give you a moment or two, and then I will write the name out for you. So give it a shot. Okay, lock in your answer. And here's the name of this: magnesium sulfate, and 7 is hepta. Okay, so you have this hydrate, and the question is, what is the mass percent H2O in the hydrate? So here's how we do a problem like this. You have to understand that percentage is equal to part over whole times 100%. The part is always smaller than the whole, so part over whole is going to be a fraction, and you multiply that times 100 to get percentage. And this is a definition, so this has infinity zig figs. So if we wanted the mass percent H2O in magnesium sulfate, 7H2O, that would be equal to the mass of H2O in the hydrate. I'm just going to write the hydrate out because that's what this is. This is a hydrate. So the mass of H2O in the hydrate divided by the mass of the hydrate. So this is the part we're interested in, and this is the whole, times 100%. I'm going to do a lot of rounding here now. And H2O is equal to 18 grams for 1 mole. And 1 mole of magnesium sulfate is equal to, we're going to call this 18.0. For magnesium sulfate, it's 120.3.
So Tony, wouldn't the equation read that it's supposed to be over the mass of the magnesium sulfate hydrate?
Yeah, but what did I
instead of
call?
just the
I call
mass
that hydrate. That's exactly what I have.
Oh, okay.
Because I'm abbreviating this because I don't want to write all that out.
Oh, okay. I got you. Never mind.
So in this case, how many H2Os are in here? 7. So we'd have 7 times 18.0 grams. What's this? It's 120.3 grams plus 7 times 18.0 grams. So that's the whole, and times 100%. Now 7 times 18 is 56 plus 70, 126. So let's see what we get for an answer. I'm going to estimate if this is 126 and this is 120, that adds up to roughly 254. And if that's 126, then it should be about 50%. Because you'll have 126 over 126 plus 126, that's 1/2. 1/2 times 100 is 50%. And so I get 51%. So it's 51% magnesium sulfate. Oh, excuse me, 51% water. How much magnesium sulfate is in here? What's the percentage of magnesium sulfate if it's 51% water?
49.
49. And how did you do that so quickly?
100 minus 51.
Right. These percentages should add up to 100. The next question is calculate this is not the way the question is worded in the book. This is different. Calculate the mass of hydrate needed to get 50 grams of H2O. So how do we do this? Well, you start off with 50 grams of H2O.
Oh, and you look up there and you know how much, yeah, okay.
And you know from this that you have 51%, which means 51 grams of H2O out of 100 grams of hydrate. You know that for a fact because that's what percentage is defined as. Percentage is not move the decimal over 2 places. Percentage is divided by 100. Now, if we take a look at this, you can see if I do this, things aren't going to be too happy for Tony. Tony will not be a happy camper because if you take a look, nothing cancels. Are you with me there? Nothing cancels. So I would get grams squared of H2O over grams of hydrate. So I don't like that. But what I could do instead is I could do this. I could use that upside down, couldn't I? And this basically says I'm going to need about 100 grams of hydrate to get about 50 grams of H2O. And I believe it's 50 point.
Okay.
Oh, I'm sorry, not 50 point, 100. And I need 2 zig figs, so I'd have to say 1.0 times 10 squared grams of hydrate. Now, the reason I insist that when people take percentage, they do this X over 100 instead of moving the decimal over is because when I tell people to use that and I give them that percent, half of my students in Chem 1A will use that, and that's wrong. That's absolutely wrong because this number is 0.0052 over 100. You don't do anything to that number. You use it exactly as written and you put it over 100. So what is this equal to? 0.00052, not this above. So I've seen this mistake too many times. I don't want people moving the decimal over 2 places. I want you to divide by 100 instead.
So Tony, that was really helpful, but I was more wondering, like, if you have like something like iron to carbonate and you have to put like 2 moles of carbonate equals, well, I guess it would be 1 mole of carbonate equals 2 moles of iron. equals
Actually-
1 mole of iron carbonate or something like that.
This is iron 2 carbonate.
Okay, so even though it's a transition
So
level,
let's try this. Let's try copper 1 carbonate.
okay,
I think this is what you're looking for. You're looking for something that looks like this. Right?
right,
So do you want to find the mass percent of one of these?
yes,
Oh, that's easy. I can do
Let's
that.
find the mass percent of this one here, okay? Copper is 63.55. Carbon is 12.01 and oxygen is 16.00, okay? So I'm gonna get out a fresh sheet of paper so you can see this without a bunch of other stuff on the paper.
it's easy for me to like add up the weights and divide by the whole and then
That's what-
multiply by 100.
That's what you're
Right,
doing.
that's what you're
I
gonna
guess
do.
then I'm
So-
unsure of how to ask my question.
So the mass percent copper would be equal to the mass of copper divided by the mass of copper 2 carbonate times 100%. So if copper is 63.55, what I would do is I would put 127.10 grams. And then on the bottom, 2 coppers is 127.10 grams. And a carbonate is, let's see, 48 is 60.01. So this is how the numbers would look. So do you understand how the mass of copper is 127.10?
Yeah,
Do you understand how the mass of copper 2 or copper 1 carbonate is 127 for
right,
the 2 coppers and 60 for the carbonate?
right.
So this is a great way to do it. And then now you just have to plug the numbers in. You don't have to show me, every iteration. Just plug the numbers in. So I got 127 divided by, I'm going to do this in my head, 187.11. And then I'm going to multiply everything by 100. And since I know this is 127-ish divided by 187-ish, that's basically the same as saying I've got 12 over 18 or let's see, 3 out of 6. No, that's not right. 3 goes into that. 4 goes into that 3 times. 4 doesn't go into that. I better stick to 6. Will go into that 2 times. It's 2/3. So when I get 2/3 for this times 100, I should get around 66%. Agreed? And my calculator spits out 67.8745%. And let's talk about significant figures here. This is good to the 100th. This is good to the 100th. So when you add those together and you get that 187.11, that's good to the 100th. So that's 5 zig figs. This is 5 zig figs. So we actually get 5 zig figs here. So that would be your answer when we round it off.
Rebecca, are you referring to like molecular and empirical formulas or just finding the moles of something?
I'm looking right now in my notes to find what I'm actually trying to
It
ask.
sounds like you're talking about either finding the moles or something or finding the empirical and molecular formula.
Let me ask you this, Rebecca. Is your question based on hydrates?
No,
So it could be anything.
right.
Basically, it could be anything about finding the formula.
She mentioned moles. That's why I think she's talking about either.
I think it might be about the empirical and molecular formulas.
Is she doing avocado's number, determining how many moles are in something, then go back to the weight?
Hang on a second.
Oh,
Whose
shit.
number?
Avocado, did I say avocado?
I
You
want an
absolute-
avocado.
You absolutely did, and we have that recorded, Greg. Oh, that's funny.
So maybe I have another question that's easier
Oh.
to answer, but I'll let someone else go before.
Does anyone else have another question?
No, not really. I just had a question about the variations of polyatomic ions and if we had to know all the eights and ites of.
Yeah, you should know that trend where it's 8, ite, hypo, ite, and per 8. And whatever the 8 is, so if you have chlorate, the ite is 1 less oxygen. The hypoite is 1 less oxygen again. The perate is 1 more oxygen. So that is always the trend for perate, ite, and hypo. Now, if you have sulfate, what is the formula for sulfite? 1 less oxygen. If you have a nitrate, what's the formula for nitrite? One less oxygen.
Is that basically all of table 2.4?
I don't know what table 2.4 is. Let me look it up real quick. Do you happen to have a page number for that?
80?
Pardon me?
80, page 80.
Thank you. Yeah, that's basically what's given. They give it to you in different places here and there. Like you see the nitrate and the nitrite. So they give you an example there. They give you the chlorite, hypochlorite, chlorite, chlorate, and perchlorate. They give you the list differently than I do. They give you the list with fewer oxygens to more oxygens. And I give you the list from more oxygens to fewer. But notice the 8 and the ite, the 8 has 1 more oxygen. Look here at nitrate and nitrite. The nitrate has 1 more oxygen. And when you see these two examples, you may fall into the trap that the 8 has 3 oxygens. But when we go down here to the sulfate and the sulfite, look at that 8. It doesn't have 3 oxygens, it's got 4. So the lesson you're supposed to learn is memorize the 8s and you can figure out the ites.
Mm-hmm. Yeah, it's because they don't all have like a perchlorate, like a per.
No, they
Like
don't.
it's only perchlorate and permanganate. Okay.
Well,
I guess basically memorize everything.
these are the only ones that were given, though. I mean, there are literally hundreds of more ions that are not given. So what are they going to give you? The ions that you're not going to run into in chemistry or the ones that you will? They're giving you the ones that you tend to run into. Okay. I hear kids fighting. I'm glad my kids are not that age anymore. But I'm not too glad because if my kids were that age, it'd mean I was younger. And now I'm just old, waiting to die. Okay, I'm not waiting to die. I'm just filling time because you guys don't have questions.
I found the origins of my question.
Go ahead.
So it was similar to number 76 in the back of the book. It said how many ammonium ions and how many sulfate ions are present in 0.2 mole sample of ammonium sulfate or whatever.
Okay, so this problem right here. Yeah?
Yeah, it's similar to that where you have to say like 1 mole of sulfate equals 1 mole of sulfur equals 4 mole of oxygen, and then use those unit conversions.
Right. And so would you like to go through that problem?
Unless if the problem next to it or something will also have that, because I do have 76 written out right here. I'm just,
Well, we can actually look at 77, which talks about acetaminophen.
yeah, that'd be perfect.
So they have the structure drawn below. And when they draw the structure, we're supposed to figure out the formula. So when we look at this, the black spheres are carbons. So can you see that there's 6 carbons here?
Right.
That's a carbon and that's a carbon. It's hard to tell, but that's actually blue and it's a nitrogen. Let me zoom in on this and maybe we can tell. Okay, I think now you can tell that this sphere right here that I have my finger underneath is blue.
Right.
So when we look at the atoms, there's 6 carbons plus 2 more for 8. Next, we count hydrogens. We like to usually do this in alphabetical order. So carbon is first, then hydrogen. The white spheres are hydrogen. And I count 9. Is everyone on board with 9 hydrogens?
Yeah.
And then there's 1 nitrogen and 2 oxygens. So I'm going to write that out here as acetaminophen. Has 8 carbons, 9 hydrogens, 1 nitrogen, and 1 oxygen. So that's the formula. And we're asked to.
What you're writing down right now.
Oh, I'm too zoomed in. I'm sorry. There we go. So they're asked you take 2 500 milligram tablets. So 500 milligrams plus 500 milligrams is 1,000 milligrams. So you're taking 1,000 milligrams of acetaminophen, which to me is a lot. That's a lot of acetaminophen. And drug companies don't use significant figures at all, not one bit. This is probably 500 point, and this is probably 500 point, which makes this 1,000 point. So 3 zig figs, 3 zig figs, you get 4 zig figs. And the reason you get 4 zig figs here is because when you add these 2 500s up, they're all good to the ones, which means now you have 4 zig figs. Okay, they ask us how many molecules in one dose? We're going to do 2 problems. The first question is going to be how many moles in one dose. And the follow-up is going to be how many molecules in one dose. And then we're going to have another follow-up. How many carbon atoms in one dose? Okay, so are you guys ready for this?
Yes.
So to get moles, we need the molar mass. 8 carbons. 8 times 12 is going to be 96, and then 0.8. 9 hydrogens. 1 nitrogen. 1 oxygen. So when we add these all up, we get an 8, carry the 1, 7, 18. 15 plus 10 is 25, so carry the 2. And then 10, 11, 12, 13. So that is the molar mass of this guy. So we would take our 1,000 milligrams And the way I would do this personally is I would write 1,000 times 10 to the minus 3 grams. And I wouldn't convert milligrams to grams. Instead, I would substitute 10 to the minus 3 for milli. That's legitimate. That's absolutely fine. Don't want to lose that decimal there. And then I would multiply by 135.18 grams on the bottom and 1 mole on the top. And if anything could make this better, it would be if I used ACE, 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 ACE. So what does ACE stand for?
Acetaminophen.
Yeah, because I don't want to write that whole darn word out. So ACE. Besides, it makes it sound cool. So when I do the work here, I know that 10 to the minus 3 times this is 1. So I'm going to have 1 divided by 135. My calculator better spit out an answer that's way smaller than 1, like 0.008. So let's see what we get. We get 0.0073975. This has 4 zig figs. This has 5 zig figs. So we get 4 over here. So this is good to the second 7, but I'm not going to round yet because you're not supposed to round early. So actually for this answer A, I would write 0.0073975, and I round out of room here. So I'm going to put mole of ACE here. Mole of ACE. And that's A. Now let's look at B. For B, I would start with this number here. And I would multiply by 6.022 times 10 to the 23 aces per 1 mole of ACE. Now here we have 4 zig figs, here we have 4 zig figs, so we round to 4 zig figs. And I get 4.455 aces, or excuse me, times 10 to the 21 aces. So when I say I have that many aces, since each ace is a molecule, it's really that many molecules. Now, from this formula here, we can see that for 1 ace, we've got 8 carbons, 9 hydrogens, 1 nitrogen, and 1 oxygen. So if I wanted the number of carbons, I would multiply my 4.455 times 10 to the 21 aces, and I multiply by 8 carbons per 1 ace, which I get from right here. And basically it's going to be this number times 8. So the answer should be around, what, 35 or 40 times 10 to the 21. And I get 3.564 times 10 to the 22 carbons. So I don't know if this kind of helps you at all, Rebecca, with that idea of using
that's perfect.
Avogadro's number, using the formula, converting to moles. This is the kind of stuff you do. So I know in the book there were problems where they said how many moles of ions. Let's take a look at a problem like that, okay? So let's say you have this formula here, aluminum nitrate, and let's say that you have 1.0 grams, and we're going to have a few questions here. 1, how many moles? B, how many moles of ions? C, how many moles of cations? Actually, I'm going to put anions. And then D, how many cations? Not moles, but actual cations. And so we're going to need the molar mass of this guy. An aluminum, one of those is 26.98, I think. Nitrogen, we have 3 of those. And they're 14.01. 14.01 times 3 is 42.03. And we've got 9 oxygens. 3 times 3 is 9. Each of these is 16. Oh, and I wrote this the opposite way of what I did above. I'm going to cross the 9 out and put O there, cross the O out and put a 9. 9 times 16 is 90 plus 54, so 144. That's only good to there. We add these up and we get 1, 0, 3, 1, 2. And I'm wondering if this is correct, so I'm going to check and see real quick. 144 plus 42 is 186. 186 plus this should be about 206 plus 6, so it works out. Okay, so for A, we're going to say 1.0 grams of AlNO3 times 1 mole of AlNO3 per 213.0 grams of AlNO3. And you can see this number is going to be small. And we only get 2 significant figures. And I didn't put the numbers in correctly. Okay, so we get 0.0047 mole of aluminum nitrate. So for B, to get the moles of ions, if we have 1 mole of aluminum nitrate, that's equal to 1 mole of aluminum and 3 mole of nitrate. So in this formula, there's 1 aluminum ion and there's 3 nitrates. How many ions are there total? 4 mole of ions. So we could say 1 mole of aluminum nitrate is 4 mole of ions. So I can start with this number here. And multiply by 4 mole of ions per 1 mole of aluminum nitrate. So I get 0.019 mole of ions. Now, how many mole of anions? Well, I would do this, 0.047 mole of aluminum nitrate. I'd start there again. But if we take a look here, can we see that for 1 mole of aluminum nitrate, you have 3 mole of NO3 minus, so that's 3 mole of anion. So here I'm going to write times 3 mole of anion. And this number should be smaller than that because it's 3, not 4. And I get 0.014 mole of anion. Now, how do you get cations? We can't use 3 mole of cations. How many mole of cations are there? 1 mole of cation to 1 mole of aluminum nitrate. So this is another way to do that type of problem, Rebecca, okay?
Thank you.
You bet. Okay, with that being said, it's 7:08. It's been great. But there's a couch right over there and it's calling my name. It's saying, Tony, come take a nap. We miss you. So without further ado, turn on your mics and say goodnight.
Later.
Good night.
Thank you.
Good night, everyone.
Thank you. Bye.
Bye-bye.